Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's DevOps.com webinar, brought to you by TechStrong, Datadog, and AWS. My name is Cody J. Brown, and I'm the host of TechStrong Learning. We have an exciting presentation ahead, but before we begin, I have just a few housekeeping notes. First, today's session is being recorded, so if you miss any of our discussion or you'd just like to share it with a friend, then the on-demand will be made available shortly after the webinar concludes. On the right side of your screen, you'll notice a couple options. If you have any questions throughout today's webinar, we want you to type those into the Q&A tab. These questions, we're going to answer them at the end of the webinar, but be sure to send them in early to make sure we have enough time to address it. If you look at the chat tab, this is just where we want you to add to our conversation. If you have any expertise in the field and you'd like to share it with everyone, this is where we want you to do so. We have two polls throughout today's presentation. One of them comes pretty early on, so I want you guys to keep an eye out on those polls so we can get those results back to our speakers today. And finally, at the conclusion of our program, we will have a giveaway for 4 $25 Amazon gift cards. So on to our discussion today. Our topic is real-time container monitoring best practices. And I'm joined today by Dan Marr, developer advocate at Datadog, and Igor Alexeyev, Data and Analytics Partner at AWS. And it is my pleasure at this time to turn the floor over to our speakers to get us started. Thank you both for being here with us today.
Well, thank you so much for that lovely introduction. I'm actually just looking at the public chat right now that you just introduced us to, and there are a number of people who say that they cannot hear anything. So if our fine people who are currently manning the back end of this platform could maybe take a look at that, that would be lovely. I, however, am going to barrel through as if everything was operating completely perfectly. All right. So as you heard in the introduction, my name is Dan. I'm an engineer on the community team at Datadog, and I am joined by Igor. Would you please
Thanks, Dan. Hi, I'm Igor Alexeyev. I'm a partner solutions architect at AWS, and I worked a lot with Datadog.
Fantastic, glad to hear it. All right, so what are we going to be covering today? Well, fairly straightforward. Here's the agenda, right? We're going to start with this, because starting at the beginning is a great place to start, the introduction and the session overview. Then I'm actually going to pass it over to Igor. He's going to talk about containers at AWS. Got a lot of really good content. I happened to be on the dry run a few days ago, and I can guarantee you there's some good stuff in there. Then we're going to pass it back to me. I'm going to talk a little bit about monitoring containers and how we kind of do those things at Datadog, and then move on to looking at some of the things that we've learned about containers and trends and things we're seeing in the industry right now, and go through some hot tips and tricks in there as well. And then just sort of spend a little bit of time speculating on what we think is coming up in the industry. And of course, the best part of any webinar, we'll turn over to the Q&A at the very end. So please do use that Q&A panel that you see there on the side. Also, one last thing, I'd like to point out that one of our esteemed container specialists, John from Datadog, is in on the chat. He'll be there to answer questions, keep things lively. So that is super. So hi, John. Thanks for coming through. All right, so I would like to open it up with a poll. All right, so we're going to start up with a poll. And this is a poll question that we're actually going to be circling back to later in this presentation. So definitely go check this poll out. All right, and the poll, of course, is what container runtime are you currently using? The wording here is extremely important. What container runtime are you currently using? Docker, Containerd, CRIO, something else, perhaps a bit more exotic. So please definitely just take a quick moment to click on which container runtime you're using the most in your current environment, and we'll circle back and talk a little bit about the results of that poll later on in this presentation. All right, I've just submitted it myself, so there we go. Okay, so I'm going to pass this virtual microphone over to Igor, who's going to get started on the AWS portion of this webinar. Igor?
Thanks, Dan. And today, so we're going to talk about containers on AWS. Hopefully, you will find this portion of the webinar helpful, useful. We'll explore different options on AWS and advantages of each. And I'll go into some details about these services a little bit later in the presentation. But first, we want to what are customers asking? I want to just kind of talk about what customers are asking us for. Customers want to build applications on AWS. They don't want to do manage infrastructure or build infrastructure. They also want to scale quickly, and they want to have security by default. Also, what are customers building? Customers are building variety of applications. You can guess, right? You yourself probably have a portfolio of applications that you're responsible for, or building, or monitoring. But anything and everything. There are mobile applications, there are shared service platforms, like CI/CD or logging and monitoring. There's this monolith decomposition movement. We're moving monoliths off on-prem and onto AWS, refactoring, breaking them up into smaller microservices-based applications. Also, there is a big example of machine learning. For example, autonomous vehicles. There is a whole, the training and actually inference can be done on using containerized infrastructure. So how customers are building it? And before we kind of jump into that, I want to present this like the high-level picture of how the compute looks on AWS. And in terms of the levels of abstraction, you can see how the amount of management that you have to do decreases as you go higher and higher. So you can probably start with EC2 if you're familiar with managing server. Who doesn't? That's how traditionally things were done on-prem. But you can move higher with ECS and EKS in Elastic Container Service, in Elastic Kubernetes Services on AWS. And you will, with ECS and EKS, you will manage the hardware, software, and networking. AWS will manage that. You'll be managing application code, data sources. And as you move higher with Fargate, for example, container orchestration, provisioning will be done by AWS. And at the highest level, with Lambda, you only manage the application code. AWS take care of everything. And in fact, Lambda recently added support for container-based images as well. So these services can certainly overlap and affect each other. On next slide, I'm going to warn you a little bit. Oh yeah, before we go to the next slide, we have a quick poll. So how many of you are using serverless technologies right now? So I'm going to say yes, but please answer the way you see fit. Because there's definitely a move towards the serverless at this moment. Okay, while you're answering, interesting, very interesting results. A lot of people are using serverless. Great. All right, so this slide is the one, it's a big and busy slide, but the idea here is we have a variety of services. We have a wide portfolio of services available to you to help build your applications on AWS, your containerized applications. You don't have to know all of them. And the idea is that everybody can find something that they need. On the next slide, I'm going to highlight just a few of these services. So if you think about like where to start and how to build on AWS, you're going to have to do a little bit of introspection, right? You have to think, what am I doing now? How I'm using containers now? And hopefully, and not hopefully, we do have a service, for your needs. So if you look at the management of the containers, so we have Elastic Container Service, ECS. We have also EKS, Elastic Kubernetes Service and we also recently added an option for Red Hat OpenShift service for AWS. Hosting we have, of course, EC2, you know that. And this is where you manage your own instances. It's just a server, just like you manage on-prem servers. This is very similar, but it's running in the cloud. And we have now AWS Fargate, it's more of a serverless product from AWS. Services that help build your applications. So this Elastic Container Registry where you can store your images. And at the application at the top level, you have Cloud Map to help you with the service discovery. And we also have AWS App Mesh that can help you with logging, routing. It's for complex microservices-based applications. So you can route north to south and east to west kind of traffic. Now we are going to go into more details of every service. And so we'll start with ECS. So these are the choice of the orchestrators, the three big choices that you have to make. It's an important choice. It's the key integration point. It will influence the rest of the decisions you make. So this is kind of where you have to start. So we have three choices here. ECS, it gives you simplicity. Kubernetes gives you open flexibility. If you're concerned about open source and love Kubernetes, this is a choice for you. And Red Hat OpenShift is an opinionated platform from Red Hat. We collaborated with the company to make it available on AWS. Now we'll go into a little bit details of each service. So what customers are telling us they love most about ECS is it's the simplicity it provides. It delivers an AWS opinionated solution for running containers at scale. It reduces the time it takes for customers to build, deploy, and migrate their containerized applications successfully. Amazon ECS powers a growing number of popular AWS services trusted by many, many customers. Next, we're going to talk quickly about EKS. So EKS is your choice for vibrant ecosystem and community around Kubernetes community and consistent open source APIs. And it gives you broad flexibility. Customers rely on Amazon EKS to handle the undifferentiated heavy lifting of security and operating Kubernetes at scale. Amazon EKS provides flexibility with the security and resiliency of being an AWS managed service. EKS is optimized for customers building highly available shared service platform based on open source. Next, Red Hat OpenShift. It's fairly new service. AWS, with the partnership with Red Hat, introduced this new option. It is a fully managed OpenShift option on AWS. It allows customers that are already familiar with Red Hat OpenShift tooling and APIs to extend easily from their data center into AWS. If you're already familiar with Red Hat OpenShift, you can accelerate your application development and deployment process by leveraging the standard API and existing Red Hat OpenShift tools for your AWS deployments. Customers, you are not precluded of using one or the other. You can mix and match workloads. For example, you can run both EKS and ECS. It's not a binary choice here. You can also add a Red Hat OpenShift as well into the mix. We offer you choices in this case. But I do want to highlight, and the picture is getting a little bit more complex if you kind of look at a broader array of services. So I want to highlight App Runner. It's a service that was launched last year. And it's a fully managed service on AWS that makes it easier for developers to quickly deploy containerized web applications and APIs. So in this case, what's happening is this is a known workload, right? Web application and backend servers. App Runner kind of knows how to run them, right? You start only with your source code and a container image. And App Runner automatically builds and deploys the web application and load balancer traffic with encryption. It will scale up and down automatically to meet your traffic needs. With App Runner, rather than thinking about your services and scaling, you have more time to focus on your application. And this is this shift to the higher level of abstraction that I mentioned earlier, where for known workloads, you will have these higher level services where you don't need to worry about not only infrastructure, but how the containers are orchestrated, how they're managed under the hood. And we'll talk later with Dan more about examples of these services. There are more of them. This is just a kind of quick look. Now, if you think, when you run your container-based applications, there are many options, right? You run it on EC2, you can run it serverless, but in terms of where this compute is running also is important. You can run it on the edge, closer to your customers, so to reduce the latencies. The AWS has local zones where these are data centers that are more spread out, closer to your customers, or you can run it on AWS wavelength, where the compute is right into in telcos data centers. So this gives you the lowest latency to the handset possible. You can also run on premises. AWS Outpost, it's a physical rack that customers can install in their data center and run containerized applications on that infrastructure. And there is also EKS Anywhere and ECS Anywhere. These are distros, software solutions that you can deploy in your own data center. And Datadog can actually monitor all of this configuration in all of the services I've mentioned. Datadog is integrated and has out-of-the-box monitoring solutions. And with this, I'm going to hand off to virtual microphone to Dan.
Very smooth handoff. Thank you.
Thank
Appreciate that. So with all of that now having been said, right, I think what we can say is that containers are worth looking at, right? If you're not currently doing anything with containers, that's amazing, by the way, because containers are everywhere right now, but kudos to you nonetheless. Well, there's a good chance if you're not currently using containers, at least in testing, your CI/CD, if not in production, then you need to have a way of understanding what's going on, right? So we're going to be talking about containers, deploying containers everywhere, all over the place. Having some capacity to have visibility on that is going to be important, right? So let's talk a little bit basically about that. And because I happen to work for Datadog, I want to talk a little bit about Datadog. And what we're looking at here is a quick screenshot. It's just a screenshot. There's a lot more that's going on, right? We have lots of stuff in the Datadog platform. This is one small portion of it. It's called Datadog Live Containers, and it enables real-time, right? We'll put quotes around that, to all containers across your environment, visibility into all containers across your environment. It takes inspiration from sort of bedrock tools that you as computer people are probably already familiar with, certainly stuff I've used in my career as a system administrator, things like HTOP, CTOP, kubectl. That's how I like to pronounce that one, kube control, right? So the idea behind live containers is that it gives you complete coverage of your entire container infrastructure. I know that's a bold statement, but we can back that up. It's continuously updated in very close to real time, as close to real time as we can get it, with resource metrics, everything from kind of a 2-second resolution, right, all the way, looking backwards in time with a time series database. That's our own special sauce that goes back through all your history. It has faceted search. It's got streaming container logs. It's got all the good stuff, right? So if you're thinking, what would be nice to know about containers, it's probably in there, right? So coupled with Docker, Kubernetes, aforementioned, ECS, EKS, other container technologies, right? Plus built-in tagging of dynamic components, et cetera, the container view gives you a pretty detailed overview of your container's health, resource consumption, logs, deployment, et cetera, And again, that's all as close to real time as we can make it, right? So, but how does that happen? It sounds like magic, right? Getting all this stuff, but the reality is that it's not, right? We run a lot of containers at Datadog. I mean, a lot of containers. We manage them all in our house using Kubernetes. We've done so for a few years now. We have a substantial Kubernetes deployment. In other words, containers are at the core of our own tech stacks, right? And as a result, we have powerful first-class support for container technology within the Datadog platform and ecosystem. Like, we want container monitoring basically to be as straightforward as possible for our own purposes, because everything we do is containerized, right? And that drives how we design the product. We use exactly the same Datadog, more or less, right? We do get access to the beta and alpha features, but we use exactly the same Datadog as our customers do. So tags, or like, labels, right? If you use a different parlance, are mature, nearly universal paradigm in computing, right? Like the idea of tags, labels, attaching metadata to things, that goes back as far as there's been, data to track, right? And when I say that, container monitoring isn't magic, it's not magic, this is what I mean. It's not magic, it's tags, right? Like, it's really it. So thanks to the metadata that's already provided, for example, by AWS, right? And the metadata that you're providing from your own deployment tooling, Terraform, CloudFormation, et cetera, right? And a few special tags, right? A little bit of our secret sauce, we'll rub it on there, that form part of what we refer to as unified service tagging. It's a strategy that we encourage our customers to employ. You get powerful, in-depth observability, not just monitoring, but true observability of your containers, more or less out of the box. And for those keeners in the audience, we're like, wait a minute, what's the difference between monitoring and observability? That's an excellent question. And I have done entire presentations on the topic. If you are curious about what the difference is, feel free to pop that into the Q&A panel on the side, and hopefully we can make a quick note about it towards the end of this presentation. All right, what's next? Magic is what's next. I just said that monitoring containers isn't magic. It's not. But Kubernetes kind of is, right? Kubernetes is kind of magic, right? And in the way that, like, really, really high-level computer science is kind of magic. Really high-level computer engineering is kind of magic, right? If you happen to be running an orchestrator of some type, and it's probably Kubernetes, but not exclusively, we've got you covered there as well, right? With exactly the same techniques, exactly the same paradigms that you're used to in your everyday environment, right? We run pretty much everything using Kubernetes at Datadog, as I mentioned earlier, right? So, and if I may, digress momentarily, we're major contributors to the code base, right? We're major contributors to open source. We're part of the committee that sort of drives that forward, right? So we've got really first-class support for Kubernetes within our platform, because Kubernetes is our platform, right? All right, so once you've got Datadog up and running, right, and you're ingesting all that data, all that delicious, high-quality data, the question is, now what, right? Well, the next step is learning, right? That should always be the next step. For everything in your professional and personal life, in my opinion, is you got to learn, you got to continuously improve, you got to continuously grow. And once you have that data and you're ingesting that data and you have a way of interacting with and manipulating and sifting through and asking interesting questions about that data, then you could stop guessing about your deployments. You can stop guessing about what your systems and your stacks are doing, and you can start introspecting. That's very powerful, right? You can start learning about what you've actually got in front of you. And that's precisely what we did, except we did it at a very large scale, as in all of Datadog, right? Which is a non-trivial sample size. And when I say all of Datadog, I don't just mean the stuff that we deployed, because that's really just one set, right? I'm talking all of Datadog, right? And what did we do with that? we have sometime in the past and can continue to produce a report from that data set. So we produce and we publish, among other things, what we call our container report, because we're not particularly creative with our naming conventions, which is fine. So we have been publishing this for a few years now, the container report, and it's becoming something of an industry reference, which we're very proud of, for trends and happenings within the universe of container technology, let's say, right? So when we first published this, it was pretty much Docker all the way down. It's no longer the case today, as we're going to be discovering a little bit later on. Our current report covers 10 points, and they're all interesting, but we don't have time to get into all of them, right? So I've selected a handful here today that I want to share with you, and moreover, give you additional context, right? And information that's not necessarily in the report itself and tied into some of the stuff Igor is talking about, right? That said, I do, of course, encourage you to check the report out. We have the URL here. We've got the QR code to access that. So take a screenshot, snap that on your phone right now. Check that out after the webinar. Please enjoy, right? All right, so hopefully you had a chance to capture that information. We'll imagine we'll make the slides available afterwards if you didn't, but I'm going to move on now to the next slide. And we'll start with this data point. Now, I mentioned Kubernetes earlier, right? And that's where I'd like to begin with the data points from the report. So Kubernetes is kind of like the elephant in the room when it comes to orchestration and containers at scale, especially in production, right? Our data show that managed Kubernetes services, such as Amazon Elastic Kubernetes Service, or EKS, right, have seen significant growth in recent years, and are still the standard for managing container environments in the cloud. So today, almost 90% of Kubernetes organizations use a managed service as opposed to running self-managed clusters. This is an enormous number, right? 90%, very, very large. If you're managing it all yourself, that's totally cool. There's no shaming going on here, right? But the reality is that most people aren't. And I think that's an important data point. By the way, this 90% figure I'm throwing around, it represents a 19-point gain from last year, right? And we expect that trend to continue. Now, speaking of EKS specifically, the adoption rates there went from around like 50% of organizations leveraging EKS to around 70%, which again is a really, really big jump, right? In fact, it represented the largest jump in managed Kubernetes service adoption among the cloud providers. And the last thing I'll mention here is that AWS has supported Kubernetes on EC2 for a long time. So this trend is substantial. This move from sort of managing things yourself to allowing a service provider to manage it for you, that trend is substantial. Organizations across the board, across every size, across every industry, are increasingly seeing the value of having a trusted partner, right, such as AWS, to manage their control plane operations for them. Now, again, if you choose to do it yourself, we at Datadog choose to do it ourselves, for example, that's fine. But again, most organizations aren't doing it. And that's important to know, right? So as we note in the report as well, containers are ephemeral, right? And while that fundamental truth hasn't changed, as an industry, our comfort level with temporality has, basically, right? This is both driving and is being driven by our capacity to deal with durable storage, with persistent identity, these sorts of important ideas within the context of containers. This virtuous cycle, if you will, of evolution is seen most notably in Kubernetes, and in particular through the increased use of stateful sets and persistent volumes, which are two sort of mechanisms inherent in Kubernetes, valid for this use case, which is great. And we say that in the report, and you can go read that in the report. But what we don't say in the report, which I think is an important question to ask, is why, right? That's the open question. We see the trend, but why? Why the trend, right? Literally, why are we as technologists, practitioners, moving in this direction? I posit and submit to you today that it's inexorable. It's an inexorable shift. So we're so used to using containers during development, during testing, during staging, in CI/CD, everywhere, right? And also in production to a certain degree. such that it just makes sense for people to start saying like, wait, why aren't we containerizing everything? Like, why do we put some things in containers and not other things? Why don't we just put everything into containers, right? That's the question. And what do I mean when I say everything? Well, I mean this, right? Well, this and more, of course, right? We're doing a lot of things in containers. But this chart shows us the top off-the-shelf images that are running containers across all industries and scales. And yes, I realize there's more than 10 on the list, but it's more fun to call it the hot top 10. So here we go. The breakdown here is by organization. By organization. So for example, literally half, in fact, just over half of organizations that use containers are deploying at least one Nginx image. That's what the chart is showing us here. In reality, it's probably more than one Nginx image, but at least one. And it's not surprising why, right? Between like straight up web hosting and proxying use cases, Nginx is a pretty, industry standard workhouse. Like a lot of, mesh technologies and proxying technologies just deploy Nginx images kind of default, so it makes sense, right? But take a look at the rest. There might be some surprises in there. Every time we publish this report, there's always something in there that's surprising to me. In fact, look at pretty much everything else on that list, other than Nginx, right? Now, with the arguable exception of HA proxy, it's all stateful services. Stateful services all the way down. In fact, if we consider images by organization in Kubernetes stateful sets only, so aforementioned Kubernetes stateful sets, the data are even more telling, frankly. As you can see, Nginx drops way down the charts, right? With the notable exception of Jenkins in that sort of under 5% spot, it is therefore all data stores of one type or another, which kind of blew my mind the first time we started seeing this happening, right? In other words, state, and in some cases like long-term, long-running state, not just stuff you're keeping around for days or months, but like for very long periods of time, in containers is a reality today, a real reality today, right? So for those of you who are already running your databases and containers, your production database load inside of containers, which we weren't supposed to do in days gone by, those of you who are doing it today, you're in good company, numbers-wise, right? So that's some validation for you and for your strategy there. Now, for those of you who aren't doing that, again, this is not sort of a name and shame situation, right? Everybody's scenario is different. The important thing, is to consider your skills and your experience and your resources and what things you want to concentrate on, right? And what do those trade-offs mean to you? And then figure out what works for you. Does putting databases and containers on top of Kubernetes make sense for you, or doesn't it? And that's an important question to ask. Don't do it just because someone else is doing it. Do it because it makes sense for you, right? And the question there then becomes, and not to beat the drum too hard here, right, is how? How do we figure out what makes sense for us? How do we figure out if I should be running my MySQL inside of containers on top of Kubernetes in EKS? Like, how does that make it? Is that a good idea? You need the right tooling, you need the right data, you need the right partnerships to interpret that data. And that's one of the areas where Datadog and AWS can really make a difference for you, right? Fair enough. So, okay, so cool. Moving right along. What's next? So Docker has been the unquestioned champion of containers basically since there have been containers, right? Now, the idea of containers, of course, existed before, before Docker, right? Chroot jails and people running BSD and Solaris, have been using container-like technology for a very long time. But Docker really brought it to the mainstream. Docker brought, this idea of containerization to everyone, kind of everywhere, all over the place, which is really cool. But Docker today is not the only game in town. All right, there are basically new challengers to the throne, if you will, right, in play. Now, in terms of volume, sheer volume, good old-fashioned Docker runtimes are still extremely dominant across the board, right? Extremely dominant across the board. And we can see here, even if we look at that poll that I asked you to ask a little bit earlier, we can see the results here. What container runtime are you currently using? And in fact, the vast majority of the respondents on the call here today are responding that they're using Docker. What's interesting here is that we got a little bit of a different breakdown from the global stats that we're seeing across the boards. The audience here today, smaller sample set, of course, the audience here today, a little bit different from what we're seeing across the board. The audience here today is actually moving away from Docker runtime at a slightly more accelerated rate than we're seeing as an industry's trend. So good for you, everybody. Good for you. All right. The question then becomes why? I know I ask this question a lot, right? Why? So we show you in the report, and that's nice to know that that's what's in the report. But what I want to know is why. Let's scratch the surface. Let's dig deeper there, right? Why are alternatives gaining both mind and market share, and why is the audience with us here today also trending in that direction? Well, there's a few reasons. But one is particularly notable. It has to do with Kubernetes, right? It's that the Docker runtime is currently being deprecated in Kubernetes. Now, I want to be very clear about what I just said. You'll still be able to use Docker images going forward in Kubernetes. There's nothing wrong with that. Fine. The Docker runtime is on the way out. Specifically as of version 1.24, if I recall correctly, and hit me up in the chat if I got that wrong. But the upcoming version of 1.24 of Kubernetes, the mechanism that still allows, or currently allows, Docker runtimes to be used, it's a tool called Docker Shim, it's going to be removed. Now we're currently 1.23 today. I think 1.24 is scheduled for release in April. Again, hit me up in the chat if I got that wrong, which is not far off. And that fact is driving at least some of that container runtime shift that we're seeing, that we're measuring, right? And again, I would love to hear from you in the chat if that's what's driving you forward and choosing a different runtime or not. Please let me know. Very, very curious about that. All right, so shifting gears here, I would be remiss if I didn't at least mention something about AWS. So here we go, right? Let's talk about AWS workloads and how and where they're being run. Now, this point has some nuance to it, right? Some nuance to it. So I want to be very clear about what the data show here. What we're seeing is a shift from running ECS workloads on EC2 instances. ECS workloads and EC2 instances towards using the AWS Fargate launch type. And again, it's easy to look at this chart and interpret something different. So I want to be very clear about it. Now, if you're not an AWS customer, there was a lot of word soup that I just threw at you right there, right? And that's fine. But the upshot here is relatively straightforward. More and more organizations are adopting a serverless mindset. It's basically what we're seeing here. A serverless mindset with regards to containers, how they're operating and running and deploying and considering the life cycle of containers. So instead of having to manage the underlying infrastructure upon which your containers are running, which is say EC2 in this instance, Fargate just takes care of that for you, right? Now there are trade-offs, of course, different reasons why you would make this decision or not. But again, increasing numbers of organizations, and in particular, as we see migrating from the ECS workloads and EC2 instances to the Fargate type, are calculating that those trade-offs are more than worth it, right? And serverless, by the way, is super cool. And I think Igor has a little bit to mention on that. We're going to get into the next portion of our presentation here together. We're just going to riff maybe a little bit and then open it up the floor to Q&A. So I propose this here basically as just some potential talking points. We're not going to go in depth on this, right? But I just want to throw these out as potential talking points for you, the audience, to ask questions about, for you to take back to your peer group, back to your teams where you work, back to your user groups, and ask questions there as well, because I think these are interesting talking points, thinking about where we're going as practitioners, as industry, with regards to containers. So I think edge computing is really neat as a paradigm, right? And I would like to see where we're going to go with in terms of putting containers right at the edge. What does that mean? How is it different? Is there something there? Is it a thing, right? I think that's going to be something interesting to explore going forward. Along with this increased reliance on containers, this explosion in the complexity and scope and scale of stacks, we're going to see an increased importance of orchestration technology, Kubernetes being the big one right now, but there are others. We're seeing increased importance of mesh technology, for example, Istio, right? And a whole host of others. I think that's going to be one of the next great generational shifts, right? Is the layers on top of the layers, right? Layers all the way down like an onion. And then thinking about those runtimes, right? We're going to continue to use Docker on our development environments, and then we're going to put containerd or something else into production. Is that going to filter back down onto our laptops? What does that look like, right? And then Igor, I think you had a couple points here as well.
Yeah. I just want to comment on your edge computing situation. So definitely there is demand there. Think of a store. Amazon Go is an example, right? You have a bunch of sensors, cameras, and you don't want to transmit all that big video stream pipe to somewhere else and do the processing. You want to do it on site. So totally see some machine learning inference workloads running locally in your store, analyzing patterns like, did customers stop in front of this setup or advertisement, or what they're doing in the store? There's definitely a need for edge computing, and specifically containers are becoming a more of a default way of deploying your compute or your applications in the compute. So there is this level to move. It's like if you think about magician in a top hat, you see this rabbit ears sticking out. If somebody is asking you, oh, give me your image, that means they run containerized infrastructure under the hood. And you see more and more of this happening. You see with Lambda, you can supply a container to run your function. App Runner I mentioned, you see to supply container. AWS Amplify, there's web and mobile apps you can run. You supply the container to run them. SageMaker endpoint. Not sure how many people use SageMaker. It's our machine learning service, a broad umbrella of machine learning services. For real-time inference for SageMaker, you're supplying a container. So that means the infrastructure underneath running is also containerized. The Amazon Batch is another service you supply containers as well. So in my mind, this container in a Docker file and definition of a container, it becomes more of a packaging and dependency mechanism because it has well-defined boundaries. It's very secure. If you don't trust the code, you want to isolate that code. You don't want to run it directly. It's especially relevant for people who are building platforms. So containers is a perfect mechanism for that. And actually, I want to comment on one of your slides where you mentioned about stateful workloads.
Yeah.
AWS has services, and I think what's happening is that the statefulness is kind of solved. So for analytics workloads, for example, you can use S3, right? You purely worry about the compute in your application. You get your data from S3, you process it, write it back out to S3. If you have lower latency requirements, we have EBS. You can your data is in EBS. It can be backed up to S3 if needed, but gives a low latency. So with AWS, you don't have to solve those problems yourself. Even if you run around your own compute, you have specific needs. Definitely, I'm a bit surprised. A lot of people have databases, and I can see I've seen several. Nginx is kind of understandable, but some of the databases, I can see the vendors behind those databases. They will be offering managed services, so it's going to be moving up and up, in a higher level of abstraction. So Redis, for example, I know already the Redis has Redis Cloud, right? So you don't need to run it yourself if you choose. And I can see most of the vendors will keep pushing it. Underneath, they might be running containers themselves, but exposed to the users will be less of a lower level implementation. So but definitely Datadog helps, whatever you choose to do, right? You can monitor, like you shown, beautiful dashboards and diagrams. I think we should probably look at the questions. What do you think?
Yeah, for sure. So I think we got some questions coming in there. let's move to the Q&A slide. Alrighty.
Oh, yeah.
Let's take a look here. Oh, our esteemed colleague is back to kick us off with some questions.
Hi guys, I'm here to get things going with this Q&A. So our first question that came up is, what's the difference between App Runner and Lightsail?
Well, that sounds like a question for Igor.
Yeah, it's a very good question because both are about simplicity. The starting points for those two services were slightly different. App Runner runs on your regular AWS console. It's the service that is on your regular console. And the target audience was developers who just want to take the application and deploy it. Lightsail is a different experience completely. You log in into different user interface. You have a much more simplified experience compared to the regular AWS console. And recently, they also, to make things more confusing, they added containers. So both about simplicity, the slightly different starting points. You're probably looking at a simplified experience with Lightsail. You might not have the CLI for the service itself. I think App Runner has a CLI. So it's a developer versus developer light experience. But both gives you the similar functionality.
I kind of like what you said there, talking about simplicity, and in many ways it's for values of simple, right? What's straightforward to one person might not necessarily be straightforward, to another person. And then, as we move forward, this idea of sort of maturing technology, right? Because we think, oh yeah, Docker's been around for and it feels like Kubernetes has been around forever. It really hasn't, right? This is stuff that's still maturing. We're still figuring out how to actually use these paradigms, right? We're supposed to be engineers. In the world of engineering, there are some things that we understand very well, like, what's a lever, what's a wheel, right? Well, Kubernetes is slightly more complicated than a wheel, right? So we're still really figuring out how to use this stuff. One of the things I find is really exciting about, what AWS in particular is not afraid to do is to sort of challenge preconceptions about how stuff is supposed to be used and go, you know what? I think this would be a cool way to offer this, or I think this would be an interesting way to leverage that, and then turn that into a service anybody can use. I think that's really neat.
Yeah, and by the way, I'm working actually with Datadog on a blog about Lightsail, how to monitor Lightsail instances. So look out for that.
For sure.
It definitely works. Yes.
Awesome. Thank you, guys. Our next question reads, what is the difference between AWS managed orchestration and managing your own clusters, and why one or the other?
So it's you have to think about how much effort you want to put. You're going to have to look into your skills and what the kind of team you have. And with a Fargate, you don't have to worry about the underlying infrastructure. You'll get the container images and you'll get the infrastructure basically configured for you. When you manage yourself, you're more involved, and it will take a little bit more effort on your side.
All right, and then our next question reads, how should I choose between ECS, EKS, or ROSA?
Great question. So yeah, I kind of touched on this in the presentation a little bit. You need to do a little bit of introspection about, look at your team, look at the skills you have. Do you have, and it's a broader question, broader than just ROSA, EKS, and ECS, because like I mentioned earlier, there are many other services. Do you have people that are familiar with Kubernetes? Then maybe Kubernetes is the right choice. If you have only developers and they know how to code, how to test, how to deploy, and that's the question. Well, deploy and scale infrastructure, maybe then App Runner is the right choice. But if you want to still try the containers, then maybe ECS is the great choice. Already have experience with Red Hat OpenShift, then maybe Red Hat OpenShift is the right, ROSA is the right choice. It's a little bit of looking at what skills you have and trying it out. You can easily try it in AWS. You don't need to worry about getting stuck with particular architectural decision. It's all about choices.
All right, so this one right here uses a couple of acronyms. So let me get this one out for you guys. So from your image stats, we could say most of the containers running on Kubernetes can be replaced by serverless, right? And it says 50% Nginx or S3 CDN ALB, 35% Redis through Elasticache, 20% PG, RDS Aurora, and 15% Elastic, AWS ES, and so on.
Right. Yeah. So that's it, right? That's it. Yes. I mean, it's the short answer to that question, right? We could say that a lot of the containers running in Kubernetes could be replaced by, and the person who asked this question said serverless. We could have easily just as said, managed service in there as well, right? And it speaks to what Igor just said, which is that it's about choice, right? It's about having the possibility of managing things in ways that make sense to you, to your organization, right? If you are a particular organization that has particular resources within your tech team, and you are absolute specialists at Redis, like just absolute specialists, could contribute to the core code base, know it inside and out, then that's a scenario where it probably makes more sense for you to be running Redis yourself, right? Probably running that on top of maybe even like bare metal somewhere, you know what I mean? Because you got it down to a science. If you don't happen to be Redis specialist, you just need we need like a key value store in, I don't know, Redis, then maybe that's a scenario where it makes more sense to have that managed another way, right? And so when you look at that chart and you go, look at all that stuff that's running in Kubernetes, how come you're not just doing that, in a serverless context or in a managed service context? That's good. That's the question you should be asking, right? The inverse, of course, is also true, right? If you are managing, because if something is 15% of a thing, it's 85% not that thing, right? So the inverse question is also true, and it's good to ask that question the other way around. But ultimately, yeah, that's an interesting observation and one that leads to healthy conversation in your professional environment.
So our next question reads, stateful services are being run in containers. Is it still advisable to run short-lived non-stateful services in containers now, or is there something else?
Yes. I mean, again, right? That's the answer. The answer is yes. Of course, it's still advisable to run, short-lived, non-stateful things inside of containers. Absolutely, that's kind of the basic use case. But I can think of another possibility there, and then that would be serverless, right? What do you think, Igor?
Absolutely, right? With serverless, you don't have to worry about the underlying infrastructure, right? And the state, like I mentioned earlier, you can manage it with EBS or S3, depending on your latency requirements. So you have choices. You can run all kind of applications. Like there is no really like a boundary or constraint here in terms of what kind of applications you can run with containers. So that's why we see this widespread adoption of container-based applications.
For sure. And, if you're thinking to yourself, and a lot of people are thinking to themselves, should we be, using technology or paradigm X, Y, Z, and that's fine. My personal standpoint on it, right, is that I like to streamline things, right? I like to simplify things. I like looking at, a complicated technical problem and going, how can I make this as simple as possible for myself? Right? Now, I can see that that's not everybody's optimization strategy, and that's fine. But that's how I look at my projects, right? And I go, I have a particular problem or a particular use case that I'm trying to address, and I just want to really just focus on that, right? And the more things that I can avoid having to deal with, kind of the better. So, in the case of a scenario where I've got perhaps a web app, right? And in the web app, I'm ingesting requests, just simple HTTP requests. I'm performing some sort of, maybe ETL or transformation on them, right? Recording some some statistical information about that transaction, and then spitting back a response, which is talk about a common model, right? That's the common model. It's the web model, right? There's a scenario where I'm looking at that and going, why am I not using serverless? Honestly, like why am I building massive web stacks and monoliths and stuff to make that go when I could just be like, I don't know, a couple of lines of code that just fires off whenever it needs to be fired off? Like, cool. And then what does this mean within the context of containers? Because we're talking about containers today. Well, Igor, serverless and containers, what does that look like for you?
Lambda. Sounds like Lambda to me. But I do want to comment on the complexity. I'm kind of from a different camp. I'm like, complexity is winning. I've given up. It's getting more and more complex. And I think what's happening is the importance here. If you take a typical monolith, right? Your monolith may be a simple application, right? But it's big. Maybe it requires big containers, in this case, big pods. And you break it up in the small one, that's great. But realistically, complexity is increasing. It's something managers cannot measure usually. So like nobody sees like, oh, my complexity went up, but great, I did something. I think the only beacon of hope, shiny light, is the spotlight that Datadog throws onto. Yeah, sorry for the cheap puns. The Datadog throws onto your applications and infrastructure, right? So you can observe your infrastructure, you can observe your application, you can see what's going on. That's the only way I can see like fighting the increase in complexity.
I agree, and I don't. We could go on this one thing. I think we could just do an hour-long presentation on just this question. To be perfectly honest, right? There's a lot to unpack here, but we ain't got time for that. But we do, I think, have time. Do we have time for one more question? I don't know. My phone turned off. I don't know what time it is.
About IoT and edge.
We can squeeze one more question in.
Squeeze one more in? Okay, cool.
Sure. So this one right here reads, when is edge computing beneficial? Is it useful for applications other than just IoT?
Well, I have opinions here.
Yeah,
what do you think,
too.
Igor?
You go first.
So is it useful for applications other than just IoT? The implicit statement there is that it's useful for IoT, which is already, like, we could unpack that on its own, but we'll put that aside for a moment, right? And we'll go, okay, I agree with that statement. Is it useful for things other than IoT? And I'll turn that around on its head. What makes it useful for IoT makes it useful for other things, right? And the idea is you actually want to get the compute as close to the consumer as possible. And when I use the word consumer here, not as in like, a person going to a store and buying a thing, like it's capitalism. The consumer in the mechanism by which the data is being used, right? So the consumer could be like an IoT device, right? And then, running on some sort of like, low power transmission network, and that's cool. It could also be really, really extremely time sensitive data, right? So data that's changing very, very rapidly, and that the expiration date on that data is extremely small, right? So, things like market trading and whatnot, right, would be the most obvious example there, right? And so if you can bring those transactions as close to the consumer as possible, there's advantages there, right? And then also thinking about like user experience. So say, for example, you've got, a web page, a mobile app, and it's loading content in the form of images or anything, right? And your company is based in one part of the world, but your customers are in another. And if you've got all of your data and all of your assets and whatnot in, say somewhere in North America, but your data, your web app or your mobile app is being used by someone in like Singapore or like New Zealand or India, then that experience, just because of the laws of physics, is going to be degraded. And so if you can bring that experience closer to the user, that makes sense. And the first evolution we saw of that is in CDNs, content delivery networks, right? Where you can bring assets closer to the user, but that's not edge computing, right? Edge computing is where we take that sort of paradigm to the next level and go, what if instead of just a picture or words, we could actually do that processing? So actual interactive applications and actually working with data and bring that as close to the user as possible, all in service of making that user experience more enjoyable.
Yeah, and I just want to add, the edge definition is kind of broad, and I like how you mentioned then that there is mobile phones, right? That's an edge as well. I mentioned earlier, there's local zones. It's these data centers are much closer to your consumers. So in that case, I was another cheap pump. We're all living on the edge, right? We are all running with our mobile computer in our pockets, and we are all interacting with these devices. So yeah, you see security camera, something. If nothing is happening, that video stream may not have enough value in itself. But if a perpetrator comes by, yeah, that's some kind of finding that can be uploaded. So, and this particular inference has to be done on the edge.
Well, that takes us to the top of the hour. So I really appreciate you both being here with us today. Quick reminder that today's session was recorded. So following this webinar, you'll receive an email with a link to access the recording on demand. You can also find it living on the DevOps website if you just visit devops.com/webinars. Real quick, our 4 $25 Amazon gift card winners are Gus S., Andrea S., Liam B., and Aditya S. So congratulations to the 4 of you. Keep an eye on your inbox to claim that gift card. And if you don't find an email, just check your spam folder. Again, Dan, Igor, thanks so much for coming here to be with us today, for putting together this slide deck, answering our questions, and just sharing your expertise and time with us. It means a lot. I'd also like to thank Datadog for sponsoring today's webinar. And my final thanks goes to you, our audience, for being here with us today. Please take a second to fill out our post-webinar survey, and we'll see you at a future TechStrong webinar. This is Cody J. Brown signing off. Have a great day, everyone.
Thank you, Cody.